Welcome to e-Padasala lecture series in computer science. As part of this program, we are going to deal with algorithm study now. The learning objectives are to understand the needs of the algorithms, to understand the role of algorithms in computer science, to know the characteristics of an algorithms. We are also going to talk about the kinds of problems that are encountered in computer science domain, and we are also going to deal with the study of the efficiency of an algorithms. Computers have become integral part of our life. Without computers, we cannot survive. We use computers for variety of applications. We use various word processing softwares to type documents. So, we use computers as part of desktop publishing. We use computers for calculations. We also use this as a tool of calculator, diary. We draw many various diagrams. We use softwares like painting, and we browse the net using computers. We use computers for variety of communications like emails, etc. We also use computers for various entertainment like video games. The same computers are used by the government as well as industry for larger applications. The complexity of these applications are complex when compared to our personal applications. We have lots of e-governance applications where lands etc., land details etc., are stored by the system, so that anyone can access these details from anywhere. We can use computers for video surveillance kind of applications. Governments use biometric applications using palm print, fingerprint etc., for variety of applications like attendance taking etc. Various e-commerce applications are there, and lots of mobile commerce applications are available, and industry use algorithms for wide variety of applications like quality testing, surface testing, for various manufacturing, process control etc., etc. If we see all these applications in the proper context, we can come to a conclusion like this. The knowledge of computers is absolutely necessary, so that we can survive in our day to day life. This kind of thinking is called the computational thinking. In short, we can say that computational thinking is the knowledge or the skill that is necessary for everyone to survive in this modern world. This kind of knowledge is what we are calling as the computational thinking. But the computer science student is supposed to know more than what you say the usage of computers for personal or any other applications. This is called the computational thinking. The students require computational thinking to solve problems, to write programs etc., in order to solve what you say the requirements of the third persons. The necessary analytical skills that is required to solve the problem is what we are calling as the algorithmic thinking. The algorithmic thinking is not confined only to the computer science. It is a generic knowledge which applied not only to the computer science, but also in other domains like civil engineering. In fact, we can say that it is not confined to any one particular area. In short, what we are saying is that the algorithmic thinking is the kind of skill set that is necessary by the student to solve the given problems. So, this becomes the integral part of any student's or professional's life. So, this is what imparted by the computer science domain. So, computer science as a domain is meant for imparting this kind of analytical skills to the students, so that the students can solve problems and write efficient programs for satisfying the requirements of the various users. What is a computer science? How to formally define it? There is no standard way of defining computer science. There are various definitions exist. One definition that captures the essence of computer science is provided by Gibson Tucker as part of what you say ACM curricula development scheme. The definition provided by them is the most apt description and definition that is provided for computer science. They say computer science is a study of algorithms. In short, we can say that algorithm is the core of the computer science study. They elaborate 4 mechanisms. One is the formal and mathematical properties of algorithms. In short, computer science as a domain should provide the formal and mathematical properties of algorithms. Computer science as a domain deals with the hardware realizations of algorithms, linguistic realizations of algorithms, and the applications of algorithms. Let us elaborate this further. What is meant by the formal and mathematical properties of algorithms? This means the studies about the various aspects like this: algorithm correctness, that is how to prove that a given algorithm is right; algorithm design, for a given problem how to design an algorithm; and algorithm analysis, given an algorithm how to analyze those algorithm in terms of space as well as time. These are the things we are calling as the formal and mathematical properties of algorithms. The second aspect said by them is the hardware realizations of algorithms. These aspects include the computer hardware for running algorithms like sequential or parallel machines, etc., etc. What is meant by the linguistic realization of algorithms? This includes the study of compilers, interpreters, linkers and loaders, etc. Finally, the last aspect of algorithm is the applications part. This includes the various tools and packages that are available for what you say solving various problems. In short, Gibson Tucker says that algorithm is the core of computer science, and in short, computer science is reduced to study the various realizations of algorithms. Since the algorithms becomes the core part of computer science, this becomes necessary for the student to know about algorithms. In short, without the knowledge of study of algorithms, the computer science cannot be what you say said to be completed. Algorithms are referred in the literature using various names. In short, we can say that algorithm is nothing but a step by step procedure for solving a given problem. This is called in different names like recipe, prescription, process or computational procedure. In short, we can say that whatever the names are, actually what we are saying is that algorithm is nothing but some sort of a procedure for solving a given problem. The algorithm study is known as algorithmics. Algorithmics is a art of designing, implementing and analyzing algorithms. The person who does these sort of activities are called algorist. Algorist is a person who is skilled in implementing the algorithms. What is the word algorithm is all about? Is it sounds different? Is it sounds new? What is the origin of all the things? Historically speaking, algorithm is a word that is derived from the Persian mathematician Abu Jafar ibn Musa al-Khwarizmi. So, he was a Arab mathematician who lived near the modern Uzbekistan. He wrote lot of books. In fact, the word algebra was derived from his works. His name was quoted as algorithm in various Greek books. So, this word is what being corrupted as the algorithm now. So, historically algorithm is nothing but a word that is derived from this Persian mathematician name. So, algorithm in the modern context refers to what you say the procedure for solving the given problem. Let us go through the key terminologies that are involved with algorithms. The algorithm is supposed to take the input and it process that particular input to give the expected output. Any legal valid input is what we are calling as the instance of an algorithm. For example, let us say we are writing a algorithm for sorting. If we give an array of numbers, we can call that particular instance of this particular problem or algorithm. All possible inputs are said to form an domain. For example, let us say I am writing the primality testing algorithm. All valid numbers can be called as the domain of this particular algorithm. The number of bits that is necessary to represent the input is what we are calling as the input size. Normally, logarithm is used to represent short form, so that the analysis becomes very important. Always the analysis is done with respect to the problem size. For example, let us consider a simple case of tea preparation, which we normally encounter in our day to day life. Can we call tea preparation as a recipe or algorithm? Yes, we can. For example, you take this as a problem. If you take this problem, then what is the input for this? The input is going to be the tea powder, etc., milk. These can be called as the input for this particular procedure. And what is the output of this particular preparation? Tea is going to be the expected output of this particular procedures, and all the utensils that are used for tea preparation can be called as the hardware of this particular procedure. In short, we can now say that using this, the tea preparation can be summarized as these steps. The first step is pour tea powder in a cup, then boil the water, pour it into the cup, filter it, pour milk, put sugar if necessary, pour it into the cup. In other words, you can say that the activity of tea preparation can be said in terms of steps 1, 2, 3, 4, etc. This is what we are calling as algorithms. In short, the algorithm is nothing but a sort of step by step procedure for solving the given problems. So, if you take the previous procedure as a standard, you can see that there are certain commonalities which can be quoted. These sort of commonalities are what we are calling as the characteristics of an algorithms. In other words, any procedure can be called as an effective algorithm if it possesses these properties. What are those properties? Let us see one by one. Input. The algorithm can have 0 or more inputs. For example, if I say sorting is an algorithm, then it should have some sort of inputs. So, I give some inputs to that, so that it can produce the output. There are certain procedures that do not require any input from the user at all. Those sort of things are also called as algorithms. Output. An algorithm should produce at least one or more outputs. You can't say that the algorithm will not produce any output. So, at least one output should be there. Definiteness. What is definiteness? All the instructions of the algorithm should be clear and unambiguous. What does it mean? For example, I can't give an instruction something like 1 divided by 0. This is not well defined, because the results I cannot predict. So, in other words, the instructions which I give as part of my algorithm should be very clear and unambiguous, and all the instructions that I provide should be unique, and order is very important. For example, if I change the order of the instructions, then I will not get the expected output. So, in other words, the order is more sacrosanct in algorithms. Correctness. Correctness is the first major requirement of any algorithm. Algorithms are supposed to produce the expected output. The output should be as expected. If it is not so, there is no purpose of writing this algorithm. So, correctness is the primary necessity of any algorithms. Then effectiveness. By this we mean that the programmer or any user should be able to trace the steps of the algorithm using paper and pencil. Traceability is one important aspect of algorithms. And finally, the finiteness. Algorithm is supposed to have the finite number of instructions. It can be large, but nevertheless it should be finite, and the algorithms are supposed to terminate. So, termination is also one of the major requirements of an algorithms. These are the additional necessary characteristics of an algorithms. Simplicity. Ease of implementation is supposed to be an integral part of good algorithms. So, ease of implementation is must, and generality is another necessity. What is generality? Generality means the algorithm should be generic and it should not be specific to certain instances. In other words, say for example, if I want to add two numbers 5 plus 3, it is better if I write an algorithm that can add any given two numbers rather than specific instances like 4 or 5. So, that is what we mean by generality. In short, these are the necessary characteristics of an algorithms: input, output, definiteness, then finiteness, then we should have some sort of correctness, effectiveness, and we should have simplicity and generality. Once the algorithms are developed, then it is converted to the program and it is implemented. So, we can compare the algorithm to the blueprint of how the problem should be solved, and we can say that program is the implementational aspect of algorithms. So, we can say that the program is an algorithm in actions. We can compare this scenario with respect to what you say a bridge constructions or a dam constructions. So, you require lot of planning. So, you require all sorts of activities should be noted down as steps, and all the things are, we can say that the algorithmic aspect of dam constructions, and the implementation part, that is the actual construction, can be what you say said as the programming aspect of the dam constructions. So, we encounter lot of problems in computer science for which these algorithms are what you say necessary. So, these problems are called computational problems. So, any problem that can be solved by the computers are called the computational problems. So, there are two aspects of computational problems. Number one is the formalization of inputs and the characterization of the relationship between the input and output should be there. So, if these two properties are adhered to, then we can say that it is a computational problems, and for these sort of problems what you say the algorithms are what you say are possible. Computers cannot solve non-computational problems. What is a non-computational problem? Any problem that cannot be solved by the computer is called the non-computational problems. A good example of non-computational problem is opinion giving or emotions. For example, I can ask a computer to multiply two long integers, it can solve it in a fraction of a second. I can also do face recognition using computers with little bit difficulty, but I can never write a program so that the computers can offer opinions, for example, about the Indian literature or Tamil classics. We cannot do that. So, similarly, the computers cannot understand the emotional aspects of the users. These are problems that are called non-computational problems. In algorithm study, we take only the computational problems as the main core, and we are trying to solve it as part of this. So, first let us classify the computational problems we encounter in computer science. The types of problems can be like this: structuring problems. So, we can say that these problems bother more about how to structure the given input for certain requirements. For example, sorting can be said as a structural problem. So, algorithm study deals a lot with these sort of problems, and search problems. So, these problems involve searching for a particular target. So, this can be ranging from a simple linear search where you have a given array, you have a target where you are trying to search for that particular target, or it can be in the context of a game where you are searching for a particular target configurations like in puzzles, etc. Algorithm study do involve lots of problems that are categorized as search problems. Construction problems, where you are trying to construct the solutions in a step by step fashion based on certain requirements. Decision problems, the problems whose output is yes or no based on certain requirements. And finally, what you say the optimization problems, where you have an objective function, you have certain constraints, and based on the constraints you are trying to maximize or minimize the objective functions. Let us take one simple example of how the algorithms are being written. For example, you take this particular case where you have a tuition center, you have some 5 students, they have obtained certain marks, etc. So, the problem is, say for example, if I want to know how many people who failed in this particular course called physics, then I can say that I can write algorithms like this. So, there are 5 students. So, I am setting up a counter, counter is equal to 1, number of students is equal to 5. Then initially fail count I am setting as 0. So, while counter is less than or equal to the number of students, fine, I am reading the student mark and assuming that 50 is the passing mark, and I am checking the student mark with respect to 50, and if it is lesser than 50, then I am trying to increment the fail count. So, you can see very well this goes in a loop, and when the counter equals to the number of students, it comes out where now the fail count has got the students who have failed in this particular course that I am going to print. So, I can call this as an algorithm itself. So, these algorithms should be more efficient in the context of computer science, because computers have limited resources like memory or processor. Therefore, it is necessary that the algorithm should be more efficient. So, we will take one simple example where we can see that the efficiency becomes a crucial consideration. For example, we will take the problem called a traveling salesperson problem in computer science. So, this problem we will encounter many times as part of this course. So, for beginners, traveling salesperson problem is a problem where the number of cities are given. The salesperson should start from a city. He has to visit all the cities at least once, then he has to come back to the original city. If any such possibility is there, then it is called a tour. So, the traveling salesperson problem is a problem where you have to find the optimal tour, that means the tour having the least distance. So, we are trying to model this as a graph. Every city becomes a node, every path from one city to another city become an edges. Assume that you have only one city, that means there is no path at all. Suppose if two cities are given A and B, you can say that there is a path A B. Imagine 3 cities are given A B C, then you can see that there are 2 paths A C B and A B C, that means there are 2 paths. So, imagine that if the cities are increased to 4, you can see this particular table, you can see that for 4 cities there are 6 paths available, and if the cities are increased to 5, it becomes 24. If the cities become 6, it becomes 120. You can see the table on every unit rise on the left hand side, on the right hand side there is an exponential growth. Say for example, if there are 50 cities, you see the number of paths that is available is such a vast number. You can see that even if the computer takes 1 second for processing a path, the algorithm will take many days to complete. In short, if we increase the problem to 50 cities, 1000 cities, say all the cities of India or even USA, find the problem becomes very difficult. In other words, what you say, the efficiency of an algorithm is a very important issue. So, that is the reason why we spend lot of time to what you say write algorithm in an efficient manner. In summary, we can say that algorithm is the core of what you say computer science domain. So, computer science primarily deals with algorithm and its realizations only. Algorithmic thinking is necessary to solve the problems, because a computer science professional is supposed to write lots of programs for satisfying the requirements of the customer or third person. So, algorithmic thinking is necessary. Algorithms can be compared with the blueprint. So, we use algorithms what you say to indicate the outline of how the problem should be solved, and we do algorithms a lot in our day to day life, where efficiency may not be of much constraint, much issue, but for larger context efficiency is must, because as we have seen just now, like in TSP, if the number of cities increase, the amount of complexity becomes more and more. As the resources of computers are very less, so efficiency becomes the crucial issue for all the things. These are the various references that are used as part of this module. You can see that this is the model ACM curriculum developed by Gibson Tucker, which gives the apt definition of algorithm study. So, with this thing we conclude this particular module. So, we have discussed the basics of algorithms as a part of this module, and in the next module we are going to deal with how to take a small problem and how to solve those problems as part of our algorithm study. With this thing I conclude this particular module. Thank you very much.